Good morning to you all. How are you? I hope you are doing amazing. How is your exam preparation going? Your exams are starting from 17th Feb. Are you prepared? Do not worry, we have time. We can still master it out. We can still score 95% in our board exams, okay? A very warm welcome to you all. Good morning, everyone. Okay, so the topic that we will be discussing today is all the important chemical reactions from our entire chemistry. So we have 4 chapters, right? In chemistry, we have 4 chapters. So from all these 4 chapters, we have around 40-ish reactions, okay? 40-ish chemical reactions, not exactly 40 reactions, okay? So if you just memorize or if you just, learn all these 40 reactions, which I will help you learn, then you can easily score good marks in your chemistry portion, okay? Hello, Classy. Good morning, Bunty. Hello, Classy. Hi, Rama. Hello, Jatni. Hi, Art by Shri. Okay. Yes, I'm good, Bunty. How are you? I'm doing good. How are you, Rama? How's your Sunday going? Oh, hi Rashi. Good morning, Indranil. Good, Madhavan. Hi Rahisha. कल से pre-board है. You have pre-board from tomorrow, huh? Yes, Adbay Shri. Hello. Do not worry. Okay, so first pre-board is of which subject? Indranil, class time is starting right now. We are starting class right now. You have science pre-board tomorrow and I am feeling, do not worry. Oh, you have science pre-board, so this is gonna help you a lot. It has all the important reactions, and if you just learn them with me today only, you do not need to worry for tomorrow's pre-board. At least from chemistry portion, you do not need to worry. And do not worry, my dear kid, you will score good in your pre-board. Focus on your boards for now. Science, okay. Bunty has maths pre-board. Namaste, Mudit. Hi, Art by Shri. Okay, Mudit, 2 hours for 1 chapter. We are doing all the important chemical reactions, okay, first of all. And so it's like not 1 chapter, we have 4 chapters combined, all the reactions from all these 4 chapters. It's not just 1 chapter. The name is all the important chemical reactions. So Adbhai Shri, you will solve the reactions, you will do the reactions with me, so it won't be a long class or whatever you feel like class duration. Maths pre-board. Rama, you have maths pre-board. Are you prepared? Mafia Gaming. Let's start. Okay, so if we start, let's see how long it takes. Missile for portion with keyword formation. Kani, we will get to your doubt. Do not worry. We'll explain the missile formation. Let's start with the chemical reactions first. Okay. Okay. Let's start with the first reaction. So it is, I believe, in the first or second page of your NCERT. Yes, Mudit, all the reactions are there starting from your first chapter till your 4th chapter, okay? Okay, so first reaction reaction is burning of magnesium ribbon in air. When you burn magnesium in air, what reaction happens? And what do you call that reaction? It is combustion, correct? Okay. Okay, so when you burn magnesium in air, we get magnesium oxide. Is it visible to you all? It is a combination reaction, it is exothermic, it is a combustion reaction, oxidation reaction, okay? Yes, classy. Dazzling white, yes. The flame, it burns with a dazzling white flame. Burns with a dazzling white flame. Okay, now you need to balance this reaction, right? It is not balanced. Now we need to balance this reaction since this reaction is not balanced. Hi Zarina. Yes, Mudit, it burns with bright light. Hi Mafia Gaming. Yes. So here on the left hand side we have one magnesium. On the right hand side also we have one magnesium. So magnesium is balanced. What about the oxygen? We have two oxygens on the left hand side and one oxygen on the right hand side. So what will we do? We will multiply right hand side by 2. Now the oxygen is balanced. Oxygen is balanced. 2 oxygen on the reactant side, 2 oxygen on the product side. Now we want to balance the magnesium. So what will we do? We have 2 magnesiums on the product side. So we need 2 magnesiums on the reactant side. Now this is a balanced equation. Okay. Make your notes with this. Okay. Yes, 2 magnesium. Next reaction, conversion of quick lime to slaked lime. What is quick lime? Do not worry, Mudit, I will let Sonu sir know. Yes, so Classy answered it. Quick lime is calcium oxide. So you guys are very well prepared for your boards. That is very good. Calcium oxide combined with water. This is quick lime. Calcium oxide is called quick lime. And after combining with water, we get calcium hydroxide, or this is slaked lime. One more name is there, slaked lime. In place of slaked lime, we can also call it, what do we call it? Yes, Mudit, I will tell Sonu sir, do not worry. Okay, what use you were asking? Sorry, I missed the question, I believe. Lime water. Classy, the name is lime water. You want the calcium hydroxide? Yes, calcium hydroxide is one. Slaked lime, or you can call it lime water. You want the use of what, Mudit? No, Rama, it's not limestone. Yes, so tell me, what are you asking clearly, Mudit? Vaishnavi, calcium hydroxide, correct. Uses of? Please frame your question correctly. Okay. You want the use of calcium oxide and calcium hydroxide. So calcium oxide, normally when you paint your walls, so we are using calcium oxide there, okay? And painting and calcium hydroxide is normally used for your making detergents and all, you know. It's a base, so we use it for basic purposes. For soaps, detergents, yes. Chalk and marble, yes. Correct. Okay, next reaction. The action, this is lime water, right? This is lime water. Now, how does lime water react with carbon dioxide? How does lime water react with carbon dioxide? So, I have seen the last 5-10 years paper of CBSE, and in one form or the other, this reaction, these two, this one and this one, these reactions are asked one part or another, okay? Either only this part will be asked, or they will ask only this part, okay? So focus on this reaction, basically revise it properly, and you know these words. What is quicklime? What is slaked lime? And lime water also, okay? Calcium hydroxide is also called lime water. So when lime water reacts with carbon dioxide, when lime water reacts with carbon dioxide, what are we getting? We get calcium carbonate. We get calcium carbonate. Okay, now there is hydrogen also there, so we will get water. Now, if we pass, there's one more condition. If we allow prolonged passage of carbon dioxide gas, what will happen? Calcium carbonate is insoluble, or you can say milky colored, insoluble. It is milky. It is milky, it is insoluble. But if we prolongedly pass, बहुत time तक we'll pass carbon dioxide gas, what will happen? This milkiness disappear. This milkiness disappear. So what exactly happens here? Prolonged passage. Then what will happen? Calcium carbonate will become calcium hydrogen carbonate. Calcium carbonate will become calcium hydrogen carbonate. Yes, classy, the milkiness disappear here. Because why milkiness disappear? Why does milkiness disappear? White PPT. Okay. Yes, milkiness disappeared due to prolonged passage of CO2, but because this thing is soluble, is water soluble, okay? Calcium hydrogen carbonate is water soluble, and due to that the milkiness disappears. Hello Satyam, because of excess amount of CO2. Mudit, the reason is not of excess amount of CO2, it is because calcium hydrogen carbonate is water soluble, while calcium carbonate is water insoluble, okay? I can write it here also, water insoluble, while this is water soluble. Hi Seema. Good morning Seema. Hi Satyam. Good morning Satyam. Okay. Next reactions. Are you counting? We have done 3 reactions, right? We have done 3 reactions till now. We have how many reactions? We have 40 reactions. How many reactions we have? We have 40 reactions, okay? So, are you ready? Next, calcium carbonate. When we heat calcium carbonate, what do we get? So what is calcium carbonate? Firstly, you need to know all the correct formulas, okay? If you do not know how to write a formula, you have that method, right? You write cation, you write anion, you write their valencies. You have cation, you have anion, you have their valencies. And what you do then? You do cross. Then you do cross. And it becomes AYBX. Okay, that's how you write a chemical formula. And do not worry, if you just memorize or remember these formulas, nothing else will be needed for your 10th class chemistry. Okay, Vaishnavi, yes, classy, 37 left. Good morning, Shilpa. Okay, see, so calcium carbonate is CaCO3. When you heat calcium carbonate, what happens? Decomposition happens. What kind of reaction is this? It is a decomposition reaction. So when you heat, the symbol is this triangle. This triangle represents heat. You are providing heat. Okay, so what kind of reaction is this? In the comment section, tell me, is it an endothermic reaction or an exothermic reaction? Okay. we get calcium oxide plus carbon dioxide. We get calcium oxide plus carbon dioxide. Okay. So tell me, okay. Yes, class 8 is in endothermic reaction. Abhi it is an endothermic reaction. Correct. Endothermic. Yes, Abhay, class C, Rama. Yes. Arambian also correctly answered. Endothermic reaction. Okay, next reaction is heating lead nitrate. Heating lead nitrate. So when we heat lead nitrate, firstly this is lead nitrate. When you heat lead nitrate, again you are doing decomposition. What are you doing? You are doing decomposition. And what kind of decomposition? Thermal decomposition. What kind of decomposition? Thermal decomposition. So just remember there are three types of decomposition: thermal, electrolysis and sunlight. Using sunlight. You call it photolysis. So thermal decomposition we have, photolysis we have and electrolysis we have. Okay. Yes. So PbNO3 gives PbO, lead oxide, plus oxygen plus NO2, nitrogen dioxide. Now this nitrogen dioxide is brown colored. Nitrogen dioxide is brown colored. Okay, so whenever you decompose lead nitrate, you get a brown gas, and that brown gas is nitrogen dioxide. Oxygen is colorless, okay? That brown gas is nitrogen dioxide. Yes, brown fume you get. Correct. Correct Abhay. Correct Vaishnavi. Now we need to balance this reaction. Let's see. We have 2 nitrogens here. We have 1 nitrogen here. We have 6 oxygen here. But we have only 2, 4 and 5 oxygens here. So what we will do? We will balance this reaction. Okay. So let's start with balancing. Start with nitrogen first. Okay, so now we have 2 nitrogens here, 2 nitrogens here. Nitrogens are balanced. Okay, then you move on to oxygen. You have lead, nitrogen and oxygen. Just write it down for your simplification. On the reactant side and on the product side. So on the reactant side you have 2 nitrogens, 6 oxygens, 1 lead. On the reactant side you have 1 lead, 5 oxygen and 1 nitrogen. So what you did, you multiplied it by 2. Now the nitrogens are balanced. So what about the oxygens now? So oxygens are 2, 4, again 4, 2, 6 and 7 here and only 6 here. So how will you balance it? You will do isko balance. Yes, you are visible. Balancing is a bit tricky, my kids. Don't worry. So you will multiply it by 4. 4 means 8. 8 and 4 means you multiply this also by 2. Then here यहाँ पे you will have 2, 6, 12, 2, 4 to 8, 10 and to 12. Done. So this will be your balanced equation. So we started with 2, but 2 was not fitting. फिर उससे oxygen was not able to balance. So for balancing oxygen, what you do? You increase the number of nitrogens here. Okay, let me do it again for you guys. Okay, so we started by 2. 2 say it was not we were not able to balance. Only thing I can solve in 10th class chemistry is balancing. 242, 242, correct. 242. Right, classic answer is correct. Photolytic means, Rama, photolytic means that you are using sunlight. Using sunlight, you are doing the decomposition. Okay? So we multiplied this by 4. Okay, on the product side we have 4, but on the reactant side we have 2, so multiply the reactant side by 2. That means this whole formula gets multiplied by 2. Now to balance these two, we balance the lead oxide. Okay, we need 2 lead on the product side. So what we'll do, we'll multiply this by 2. Now check, your nitrogen is balanced, your lead is balanced. What about the oxygen? The oxygen will get balanced on its own. We have 6, 2 times 12 oxygen on this side, and we have 4 to 8, 8 plus 2 plus 2. That means 12 oxygens on the product side. And this is your balanced equation, okay? So sometimes it might get complicated. For example, in this one, oxygens are present in 3 places, right? So rather than focusing on oxygen, try to focus on the least, nitrogen and lead. Firstly, try to balance nitrogen and lead. If you do balance them, then oxygen will come into its place, okay? But most of you answered correctly, so I believe you understand balancing really well. Hold on a second. Yes, Abhay, that is the correct answer. And RM, if you can balance the reaction, that is a very good thing. You can score good marks. If you did not balance it properly, you will lose marks, even if you write the products and the reactants correctly. Okay. Yes, Abhay, it is correct. So RM, it is not about being tough or easy. It does not define if you are fool or not. Okay. So just focus on your boards for now, and don't let marks define you, okay? Okay. Heating hydrated iron sulfate. So when you heat iron sulfate, what is iron sulfate? Hydrated iron sulfate I've written. How many iron sulfate is FeSO4, okay? Iron sulfate is FeSO4. Hydrated means it has water of crystallization. It has water of crystallization. And how many water of crystallization does it have? It have 7 water of crystallization. It has 7 water of crystallization. Thank you, Royal Gamer. Yes. Yes, so how do you, heating means it will get decomposed, okay? Heating means again it will get decomposed. These all are decomposition reaction. And what kind of decomposition we are doing? We are doing thermal decomposition. Okay, so if you heat iron sulfate, what do you get? Okay, on further heating, this was hydrated, so what we lost, water of crystallization are lost. But if you further heat iron sulfate, so what will we get? Color, so wherever color is there, I will tell you. So this color is white. FeSO4 is white colored. Somehow brown colored gas was evolved, correct? Plus again balance this one. I'm waiting for your answers. Balance this reaction. The decomposition of iron sulfate. Green to white to brown. Yes, this is green colored, this is white colored, and iron oxide is brown colored. Okay, balance this reaction. Correct, Abhay. Ferric oxide, sulfur dioxide, sulfur trioxide. Yes, these are the products. Correct. This is your reaction. So when you decompose hydrated iron sulfate, firstly it lost the water of crystallization. It is green colored, but after losing the water of crystallization, it turns white color. Okay. That green color was due to these water of crystallization. 7 water of crystallization, okay? Then further decomposition of iron sulfate will give iron oxide, sulfur dioxide and sulfur trioxide. Okay, now balance this reaction. Namaste Prashant. Yes, Vaishnavi, the answer is correct. So none of you is answering about balancing this reaction. Okay, I think one of you answered correctly. Yes, if we just add 2 on the reactant side, this reaction will get balanced. You have 2 iron, sulfur, 2 sulfur here, 2 sulfur here. What about oxygen? 3, 6, 7, 8. 8 oxygens are on the product side. How many oxygens are there on the reactant side? You have 4 times 2, which are 8 oxygens on your 8 oxygens on the reactant side. So all the atoms are balanced. Iron, sulfur, oxygen, all are balanced. Four what? Not 4. We have 2 FeS, so 4. Okay, Vaishnavi? Moving on. Silver chloride. This is photolysis. This is photolysis. Photolysis means the decomposition is happening in presence of sunlight. The decomposition is happening in presence of sunlight. Okay, using sunlight we are decomposing. Again, it is an endothermic reaction because sunlight energy is getting consumed, absorbed. Okay, so if you decompose silver chloride or bromide for photolysis, normally we are doing thermal decomposition, the sign we use is this triangle. Okay, but if we are doing photolysis, we are using sunlight, so the symbol is this H nu. Okay, the symbol is H nu, so we'll show it by H nu. What we get Ag plus Cl2. Again, this reaction is not balanced, so what you do, just put 2 here and 2 here. Similarly, silver bromide, decomposition of silver bromide will give next one is electrolysis of water. Electrolysis of water. Yes, Abhay, correct. Two Ag plus Cl2. Done. Done. Electrolysis means you are giving electricity for the decomposition to happen. You are giving electricity, you are providing electricity. Okay, so we have H2O, and if we provide electricity, what we get? H2 plus O2. Okay, can you tell me what will we get on the anode and what we will get on the cathode? What we will get on the anode and what we will get on the cathode. This is balanced. This reaction is balanced. You can check on the reactant side, we have 4 hydrogens. On the product side, we have 4 hydrogens. On the reactant side, we have 2 oxygens. On the product side, we have 2 oxygens. Now just tell me the answer. What will we get on the cathode and what will we get on the anode? Anode means negative. 2 हाइड्रोजन जाएगा और कैथोड पे ऑक्सीजन. No, Adambian, I don't feel cold. Correct, Classy. Correct, Mudit. Abhay is also answering correctly. So, on the cathode, we have hydrogen gas, and on the anode, we get oxygen. Okay? This is important. They do get asked. Now there is this section called competency based questions. So there they will check your knowledge. Not this reaction they will be asking straightly. They will tell you this gas is evolved at the cathode, this gas is evolved at the anode. What is the, which gases are those? Identify those gases. Okay. Now there are some combination reactions that are left. There are some combination reactions that are left. Very basic. Carbon combines with oxygen, we get carbon dioxide. Hydrogen combines with oxygen, we get water. Now again, no need to balance, you just do 2 here and 2 here. Okay, these are some basic combination reaction. Rathod and Vaishnavi, correct. Hi Sneha. No worries, Abhay. And next reaction, displacement reaction. Displacement and double displacement. So majorly question comes from both. One question from displacement, you all remember it, I believe. This one, copper sulfate combines, reacts with iron, and we get iron sulfate plus copper. Color batao. Copper sulfate is hi Shreya. Copper sulfate is blue colored. Okay, but after reacting with iron, it loses its blue color. After reacting with iron, it loses its blue color. Iron sulfate is green in color. Iron sulfate is green in color. Okay. Now, some double displacement. One more displacement reaction is there. Zinc sulfate reacts with sodium. Zinc sulfate reacts with sodium and we get sodium sulfate plus zinc. Now for this you remember the reactivity series, right? Yes, it becomes colorless green. Somebody saying green, sky blue, exothermic, blue vitriol. What are you guys answering? I'm getting lost here. NaSO4. No, classy, the answer is Na2SO4. The valency displaces weaker elements from its compound. Yes. I'm asking, do you remember the reactivity series? Firstly, we'll balance it. We have 2 here. And I believe everything is balanced. Right. So, an easy mnemonics I can give you for remembering the reactivity series, my dear kids. Yaad hai? Okay, so batao abhe. Tell me. Hold on a second. FeSO4. Oh, copper is green. Sorry. Yes, correct. FeSO4 is white. Copper is green. Okay, let me correct it. Yes. So, copper is green colored and FeSO4 is white. So, again, color changes from blue to green. Color changes from blue to green. Okay, so we have this is the simple mnemonic to learn the reactivity series. Okay, please stop calling me a careless zebra. Instead, try learning how copper saves gold, platinum. This is the simplest mnemonics, okay? This is a reactivity series that will help you throughout the metals and non-metals. So please say potassium, stop sodium, calling say calcium, me magnesium, A aluminum, careless carbon, zebra zinc, instead iron, try tin, learning lead, how hydrogen, copper saves silver Ag, gold Au, platinum Pt. Okay, this is the simplest mnemonics to learn. Yes, to learn the reactivity series. Yes, okay, Abhay answered. Hi, Golu. Okay, you are already writing the reactions, I believe. Done. So the next reaction is double displacement reaction. So double displacement means what happens is you have exchange between the cations and anions of two compounds. Exchange between the cations and anions of two compounds. What are cations? Cations are the positively charged ions. What are anions? Anions are the negatively charged ions. Okay. So when you treat sodium sulfate is Na2SO4. Sodium sulfate is Na2SO4 with barium chloride, which is BaCl2. Okay, what products are you getting? We get barium sulfate plus sodium chloride. We get barium sulfate plus sodium chloride. Okay, barium sulfate. What does this arrow means? This arrow means it is an insoluble salt. Barium sulfate is an insoluble salt. We get a white precipitate. Insoluble salt means precipitate. The salts that do not dissolve but become a precipitate. Okay, so this is white colored precipitate. Okay, white PPT. Yes, white precipitate we get. Yes. Okay, as you might be known as a sentence. No hydrated FeSO4 is green, but that was not hydrated. In the last reaction, what we got, it is not hydrated. Yes, that was my mistake. It was not hydrated. It was only FeSO4. That's why it is green. It is white colored. Okay, if it had water, if it had water crystallization, it would be green colored. Okay, potassium iodide and lead. Potassium iodide. You just put 2 there. Potassium iodide, which is Ki, plus lead chloride, PbCl2. We get lead iodide plus KCl. Okay, again in here also we get a precipitate. In here also we get a precipitate of lead iodide, which is yellow color. Yellow colored precipitate of lead iodide. Now in this question, particularly in this reaction, sometimes the examiner has asked which is the soluble part. In MCQs only, they ask which part is soluble. So you know this BaSO4, barium sulfate, it is insoluble, it is white colored. So the soluble part which is present in the aqueous solution is sodium chloride. So this is the soluble part. Okay, so that's how you remember it. When potassium iodide reacts with lead chloride, we get a white precipitate of lead iodide. Okay, so that means this KCl is your aqueous solution, soluble part. KCl is soluble part. Hi Asfi, sorry, your name is Asfi. Hi Asfi. Yes, so do remember the colors here. Barium sulfate is white colored. Iron sulfate is also white colored. Barium sulfate is white colored. Lead iodide is yellow colored. Lead iodide is yellow colored. Okay, what are the color of nitrogen dioxide? Nitrogen dioxide is brown colored. Okay, next reaction. Potassium bromide and barium iodide. Potassium bromide and barium iodide. Do not worry, Arambian, you will solve it. Just revise properly. Potassium bromide reacts with barium iodide. And what product we get? So again, it is a double displacement reaction. So there will be an exchange of cations and anions. There will be an exchange of cations and anions. So we get BaBr2 plus Ki. Now you need to balance this reaction. I believe this is balanced. Hi Ronak, hi Sagar. Do not worry, Arambian. Again, we'll solve it. I have solved the complete sample paper. Me, Tanvi, Aditi ma'am, and JJ ma'am also. So you can check it out. Hi ma'am. Hi Sneha. Yes, the reaction is balanced. KBR. No. Only study your reaction is not balanced. Hi Ronak, your reaction is not balanced. Do not worry, Abhay, you will score good marks till you have time. Just follow the master plan that I've given you. In there, you have all the important topics, plus focus on the revision. Do not start anything new, but try to maximize or, try to utilize your knowledge in a better way. Whatever you have learned, my dear kid. So for now, just focus on your studies, okay? So hi Seni, my name is Ekta. I'm Ekta ma'am. Okay Ronak, your science exam is tomorrow. Okay. So Rama has maths exam, I remember. Ronak has science exam. Most of you have science exam. 1, 2 have maths exam. Yes, Ronak. Okay. So redox reaction. In redox reactions, we have two parts. Firstly, what is the redox reaction? A redox reaction is a reaction in which both oxidation and reduction are happening simultaneously. What is oxidation? Addition of oxygen or removal of hydrogen. What is reduction? Addition of hydrogen or removal of oxygen, right? These are the simple definition. So what is oxidation? Oxidation means addition of oxygen. For example, we just did a reaction. Carbon combines with oxygen. This is an oxidation reaction. Okay? Similarly, one more reaction is there. Copper combines with oxygen and we get copper oxide. Copper is brown in color. Copper itself is brown in color. Copper oxide is black in color. What are you guys saying? No, Pro Insan, I'm not having, it's just AC is there, so that's why it is black color. Thank you for the concern though. You have SSC, okay, so you're from Maharashtra. Hi Namrata. Oxidation. Hi Sagar. Oh, you are from Ronak is from Ishar. Okay. So yes, Abhay answered correctly. So this is one of the important reactions. So this is an oxidation reaction. Copper combines with oxygen, we get copper oxide. Copper is brown colored, copper oxide is black in color. Okay. Then this copper oxide, if this copper oxide combines with hydrogen, this is a reduction reaction. What are we getting? Again, we get copper plus water. Redox, right? Copper black, copper back. Okay. Next reaction. How does acids react with metal carbonates or metal bicarbonates? Acids react with metal carbonates and metal bicarbonates. So acids are acids obviously. Metal carbonates or metal bicarbonates are basic in nature. So whenever an acid and base reacts, we get a salt. Plus hydrogen gas plus water plus carbon dioxide that are optional. Okay, that will depend what reactants we are using. For example, in case of metal carbonates and in metal bicarbonates, what are we getting as a byproduct? We are getting carbon dioxide. We are getting carbon dioxide plus hydrogen is also, plus water molecule is also there. Okay? Okay, Vaishnavi, I'll try to mention them also. Oh, you are from West Bengal. Okay, so when acids react with metal carbonates or metal bicarbonates, so let's say we have an acid reacting with metal carbonates / bicarbonates. So I'm giving you a general reaction. What are we getting? Salt plus water plus carbon dioxide. Salt plus water plus carbon dioxide. Okay, so HCl, any metal carbonate you can give. Let's say I'm taking Na2CO3. What product am I getting? I'm getting a salt, NaCl, plus H2O plus CO2. You can already, okay, we need to balance this reaction. So if we put 2 here and if we put 2 here, is it balanced? Yes, it is balanced. 2 to 10. Physical state, if you want, liquid, sodium carbonate, solid, liquid, gas. Now how does acids react with metals? How does acids react with metals? Yes, Abhay, correct. So when again acids react with metals and we get a salt, plus hydrogen gas is evolved. Plus hydrogen gas is evolved. So again, if we use HCl plus sodium metal, if we are using, we get a salt NaCl plus hydrogen gas is evolved. These are general reactions. So mainly, if you remember the general formula that acid reacts with metal carbonates, metal bicarbonates, क्या बनेगा? Salt बनेगा, salt, water and carbon dioxide will be there. But if acid reacts with metals, what will we get? We will get salt plus hydrogen gas. Salt plus hydrogen gas. Okay. So in here also, if we get it, so we need to balance it first. This is balanced. So, hi Golu. Yes, Ronak, correct. Salt plus hydrogen gas. Don't use that. Golu, that's a very bad distraction. Just deactivate it or delete it. It's not needed for you now. Hi, Kirti. Okay. Then how does acids? So normally when we are talking about acids reacting with metals, hydrogen gas is evolved, okay? But this hydrogen gas is evolved only when you are treating them with HCl and H2SO4. Sulfuric acid and hydrochloric acid, only in these two acids, only in the case of these two acids, hydrogen gas is evolved. But in case of nitric acid, you have just two exceptions. Nitric acid ke case mein no hydrogen gas is evolved. In case of nitric acid, no hydrogen gas is evolved. But if you have magnesium or manganese, only these two metals, only these two metals evolve hydrogen gas reacting with nitric acid. Rest all metals do what? Nitric acid plus metal. What are these metals? These metals are except magnesium and manganese. These are not magnesium and manganese. All the other metals. What we get? We get a salt plus no hydrogen gas. We get water. Okay? Yes. Only in case of magnesium and manganese, nitric acid will evolve hydrogen gas, okay? Because these two metals are very reactive, okay? They can displace hydrogen gas, okay? Baki, why does it happen? Because your nitric acid is a strong oxidizing agent. Oxidizing agent means it adds oxygen very fast. So as soon as you get hydrogen, it adds oxygen and we get water. As soon as it gets hydrogen, it adds oxygen, and we get water, okay, because it is a very strong oxidizing agent, okay. So that's why only in case of magnesium and manganese. And why does that? Because these two metals are very reactive. Before this reaction happens, they just evolve the hydrogen gas. One more thing, whenever hydrogen gas is evolved, it evolves with a pop sound. What kind of sound it makes? Pop sound. So sometimes if you want to know you have metals or non-metals or you know what kind of reactions, so there will be, if in any reaction hydrogen gas is evolved, the simple indication is pop sound, which is of hydrogen gas, okay? Pop sound, yes. Yes, other metal. Yes, and also one more thing, when you react them with magnesium and manganese, the nitric acid solution should be really dilute. Because it is a very strong oxidizing agent. No reaction will happen, it will just oxidize your product. Yes, hydrogen means pop sound. It is used to make explosives though. Okay, moving on to next reactions, metals with bases. Firstly, metals and bases have the same nature. Bases also donate electrons and metals also donate electrons, okay? So, very less reactions are possible in between them. But there are some reactions that are important from your point of view, from board exams point of view. Zinc reacts with sodium hydroxide and we get a salt. What is that salt? Na. We get sodium zincate plus hydrogen gas is evolved. Sodium zincate plus hydrogen gas is evolved. Similarly, aluminum also react. See, the zinc and aluminum, why do they react? Because they form amphoteric oxides, okay? Because they form they have amphoteric nature, okay? They can react with both bases and with acids. They can react with both bases and acids, okay? So next one is aluminum. When aluminum combines with sodium hydroxide, we get this is sodium aluminate. This is sodium aluminate. Yes, lead is also. Lead oxide, zinc oxide, aluminum oxide. Both acids and base. Yes, reacts with both acids and base. Correct, Vaishnavi? Correct, Abhay? Yes. Okay, now how does acids react with bases? Neutralization reaction, right? But there are three types of reactions that can happen. Three types, okay? When your strong acid reacts with a strong base, we get a neutral salt. When a strong acid reacts, we know now acids react with bases, we get salt plus water. What do we get? Salt plus water, right? Now these salts can be of three types depending on the type of acids and bases that we choose. So if we have a strong acid reacting with a strong base, we get a neutral salt, okay? So for example, if we have HCl, which is hydrochloric acid reacting with sodium hydroxide, what do we get? If we have HCl, which is a strong acid reacting with a strong base, sodium hydroxide, we get sodium chloride. We get sodium chloride plus water. The sodium chloride is a neutral salt. Sodium chloride is a neutral salt. Similarly, if you treat a strong acid with a weak base, so let's say if we are trying to treat HCl with a weak base, which is aluminum hydroxide. Aluminum hydroxide. So what kind of salt will we get? We get an acidic salt because the acid is strong and the base is weak. So the type of salt that we will be getting is an acidic salt. Okay. In this case, we will get AlCl3 plus H2O. Okay. Again, I believe this is balanced. 3, 6, Okay, next one, when a weak acid, if a weak acid reacts with a strong base, what kind of salt we are getting? We are getting a basic salt. What kind of salt we are getting? We are getting a basic salt. Yes, Abhay. Yes, weak acid, strong base. Yes, Rama, you have 100% confidence. Josh. Okay, so weak acid, CH3COOH. Acetic acid is a very weak acid. Ethanoic acid, acetic acid, it is a very weak acid. Both are the same name, okay? One is IUPAC name and the other is a common name. When reacts with sodium hydroxide, we get this is sodium ethanoate. Sodium ethanoate. Okay, this is a basic salt, okay, because the base part is strong in this one. Hi. Prakash, the timings will be there on the community. You can check them out. Chlor-Alkali process. The next reaction is Chlor-Alkali process. Okay, so we have a, what do you call, a brine. We have a brine. Okay, what is a brine? It is a concentrated solution of sodium chloride. Concentrated salt solution, okay? Concentrated solution of sodium chloride. And if you pass electricity through it, do not worry, marathon. This is a marathon going on, Rama. What marathon are you talking about? This is one of the marathon. Okay, if you pass electricity through it, we get sodium hydroxide plus H2 plus Cl2. Now tell me which you get at anode and which you get at cathode. The name is caustic soda. We call this caustic soda. So tell me what am I getting at the anode and what am I getting at the cathode, because it is an electrolysis process, right? We are using electricity to decompose it. So, and this is called brine. So tell me what are we getting at anode and what are we getting at cathode? Okay, Abhay answered it. So hydrogen on cathode and Cl2 on anode. What about NaOH? So tell me, where will we get NaOH? Sodium chloride plus water. We have a solution. Brine we have, right? And if we pass electricity through a brine, what we get? We get sodium hydroxide, NaOH, right? Then what else is left? Hydrogen gas is left, Cl is also left, H2 is also left. So we get hydrogen and chlorine gas, okay? This chlorine gas is very important. This chlorine gas is used in the next process for the formation of bleaching powder. For the formation of bleaching powder. What is bleaching powder? It's calcium oxychloride. Calcium oxychloride. Okay. So again, correct. What about NaOH? I'm curious about NaOH. Yes. So near cathode we get hydrogen gas, near anode we get chlorine gas, and near cathode also we get sodium hydroxide. Okay, it is also present near cathode. Yes, Manish, correct. And if we use this chlorine gas and if we pass it, if we use this chlorine gas and if we pass it through calcium hydroxide or lime water. This is lime water. If we take the chlorine gas from the Chlor-Alkali process, firstly, why do we call it Chlor-Alkali? Because there is chlorine gas and there is an alkali. There is a chlorine gas and there is an alkali we are getting from this process. That's why we call it Chlor-Alkali process. Okay, now how do you synthesize bleaching powder? You use bleaching powder to bleach clothes, you know, bleach wood pulp. Okay, so that's how you use, and also for disinfecting also you use it. Okay, so can you tell me what is the bleaching agent? What is the bleaching agent in case of bleaching powder? This is not the bleaching agent, CaOCl2. It is bleaching powder, but what is the bleaching agent? Which part is there which does the bleaching action? Okay, so firstly we'll synthesize it. Answer me in the comment section. Calcium hydroxide. Okay, so calcium hydroxide is lime water. If we pass chlorine gas from calcium hydroxide, we get calcium oxychloride. We get calcium oxychloride plus water. Okay, calcium oxychloride plus water. This is bleaching powder. This is bleaching powder. So tell me, yes, Manish answered it. What's Sangan, what? What did you ask? The question is lost somewhere. Okay, so Sangan, what did you ask? Tell me your doubt. Yes, Manish, you can ask your doubt. Hello, ma'am. Good morning. Asfi answered the question. Yes. Hello. Good morning. Okay. So in this, the bleaching action is caused by Cl2. The bleaching action is caused by Cl2. It is the bleaching agent. What is the purpose of this whole form, CaOCl2? The purpose of it is to store this chlorine gas, okay? Because this will act as the bleaching agent, okay? Because chlorine gas ko store karna is very difficult. That's why we store it as calcium oxychloride, as the bleaching powder. And the bleaching agent or the bleaching action is caused by chlorine gas. Chlor-Alkali process. So, slaked lime and lime water. How are you? I'm good. No worries, Abhay. Hold on a second. So Rudraj, I have covered it for all the important topics. It's in the video, 30 days master plan, all the important topics from this chapter only. Okay. Hold on a second, let me answer Sangan out. Okay, so chlor-alkali process, when you take a brine, which is a concentrated solution of sodium chloride, concentrated salt solution, brine, and when you pass electricity through brine, it decomposes as sodium hydroxide, and hydrogen gas and chlorine gas are also evolved, okay? It decomposes as sodium hydroxide. Alongside we get hydrogen gas and chlorine gas. This chlorine gas, normally we use it to prepare bleaching powder, okay? This sodium hydroxide is called caustic soda, hydrogen gas and chlorine gas. Hydrogen gas is evolved at cathode. Sodium hydroxide is also evolved is also present near cathode, and at anode we get chlorine gas. Okay, I hope it is clear. This was the chlor-alkali process. We are getting chlorine gas and an alkali. What are alkali? Alkali are those bases which are water soluble. Alkali are those bases which are water soluble. Okay. Okay, Manish, your doubt is what gas is associated with effervescence. Okay, Manish, nice doubt. So, effervescence means bubbling. Whenever any gas is present in a solution, you have a solution, right? Let's say you have this solution. Okay, if you have this solution, okay, if you have this solution and some reaction is happening there and you have some gas, carbon dioxide, hydrogen gas, any gas is there, and if it bubbles in there, you have bubbles of that gas trying to move out of it, you know, bubbling effect. That bubbling is called effervescence. That can be caused by any gas, carbon dioxide, hydrogen gas. Any gas can cause the effervescence, okay? It's not always carbon dioxide gas, okay? So effervescence means the bubbling of any gas from a solution, from an aqueous solution or any solution. Bubbling of gas is called effervescence. I hope you asked about the effervescence. Yes, brine conduct electricity. Brine, yeah, because it is in a solution, na? It's a concentrated solution, but it is a solution. So this will be dissociated as Na positive and Cl negative, that will conduct electricity as long as there are ions. Unless you take solid, only in the solid form they will not conduct electricity. In molten state and in aqueous solution, concentrated dilute, kaisa bhi ho, they will conduct electricity. Okay. Yes, brine will conduct electricity, Meera Kumari. Sangan, solid substances are you asking? So that depends. If they have free ions, so you have ionic compounds, you have covalent compounds. In covalent compounds, they are covalent bonds, bonds formed by sharing of electrons. For these kind of compounds, electricity conduction is not possible, because electricity conduction दो चीजों से होता है. It happens because of two things. You have ions or you have free electrons. Either you have ions or you have free electrons. If any of these things is there, electricity conduction will happen. Okay. So for covalent compounds, what happens? No ions are there, no free electrons are there, because bonds are formed by sharing, not transfer of electrons. So covalent compounds, they do not conduct electricity. But if you have an ionic compound, they are formed by transfer of electrons from a cation and anion. Okay, from transfer of electrons. So they have ions and electrons. But in solid state also they do not conduct electricity, because in solid state they are compact, they are closed by, they are as one form. Okay, you need to break that. So what do? You make an aqueous solution of it. Either you melt it, melt करने से क्या होगा? You will get Na positive, Cl negative, right? By melting you will get ions. Okay, and these ions will conduct electricity. So in solid state, no, they will not conduct electricity. Even ionic substances will not conduct electricity. What you need to do? Either you make an aqueous solution of them or melt them. Okay, in molten state or in aqueous solution they will conduct electricity. Yes, in covalent bond also there is polar covalent bond, non-polar covalent bond, but that is due to the electronegativity difference. The charges are very minute. If I give you the correct range, so in Na positive, Cl negative, you have, let's say, +1 and you have -1. Okay, you have +1 and -1. And let's say I'm talking about HCl. Let's say I'm talking about HCl, which is a polar covalent bond. It is a covalent bond, but it is polar, so it has slightly positive and it has slightly negative. So that +1 and +- के compare में, this is 0.00909 ऐसे करके, इतना कम है. It's very less. Okay. So even if they do have some charge, partial charge, but it's not enough to conduct electricity. कहाँ +1? There is +1, -1, full +1, -1. This is 0.0009. This much charge is there. Okay? Just a quantitative reference I'm giving you guys. This is not the exact value, but just a quantitative reference. I hope Manish, your doubt is clear. No, sorry, Sangan's doubt was there, right? Okay, next one is formation of baking soda and washing soda. So how do you synthesize baking soda and washing soda? Firstly, what is washing soda? Sodium carbonate, that is washing soda, right? Washing soda is sodium carbonate. How many water of crystallization it has? It has 10 water of crystallization. How many types are existing? I only listened to organic component, sigma, pi, coordinate. I think that sums it up. Only these. We have majorly ionic, we have covalent bond, we have ionic bond, and we have coordinate bond also. Okay? James Bond. Okay, formation of baking soda and washing soda. So how do you synthesize baking soda and washing soda? That is also one of the important reaction. So firstly, you synthesize baking soda. Sodium chloride, hold on a second, sodium chloride plus So if you take, again, this is brine, you take a aqueous concentrated solution of sodium chloride, and if you add ammonia, if you take a concentrated solution of sodium chloride and if you add ammonia and carbon dioxide, ammonia and pass carbon dioxide gas through it, what do you get? You get baking soda. NaHCO3 plus NH4Cl. Okay, what is left there? NH3 is left, Cl is there, okay, and one hydrogen is also left. So we have NH4Cl. This is, what is this? This is baking soda. This is baking soda. Okay? This is baking soda. Okay. If you decompose baking soda, if we decompose baking soda, what do we get? We get soda ash actually plus H2O. Ma'am, I have doubt. Tell me your doubt, Sagar. Solvay process defined like a board. Answer. This is Solvay process though. This first reaction is only the Solvay process. Yes, tell me your doubt. Okay. And if you add 10 water of crystallization, you get washing soda. Okay, so whenever you are writing, explaining Solvay process, so firstly you need to give a definition to it. 2-3 lines a definition, and then you give the proper reaction, that this is the reaction. Okay, and then explain after the reaction what is happening in the reaction. Okay. See, we have done 20 reactions, 20 are left. Okay, so if you have any doubt till now, or you have any general doubt in chemistry, so you can ask it. I'm giving you 5-minute time, okay? A 5-minute break also and a 5-minute time also. Whatever you say. Baking soda formation, re-explain. So baking soda's formation. Hold on a second, Sagar. So baking soda, how do you synthesize baking soda? You synthesize baking soda by a Solvay process. What is a Solvay process? It is an industrial process to produce. What did you not? So yes, just drop your doubts, whatever doubts you have, in a sequential manner. I will try to answer each and every doubt. Till then, I'll explain the Solvay process again. He asked the preparation of, baking soda. So how do you synthesize baking soda? I take a brine. Brine is a concentrated solution of sodium chloride. Okay, we take brine and we add ammonia. We add ammonia to it and pass hydrogen gas through that solution. So we take a brine, let's say this is brine, NaCl plus H2O, and we add ammonia to it, we add ammonia solution to it, and after adding ammonia, we pass carbon dioxide gas. After adding ammonia, we pass carbon dioxide gas. So what we get? We get baking soda. Baking soda, okay? What is baking soda? Baking soda is sodium hydrogen carbonate. Baking soda is sodium hydrogen carbonate, okay? What is baking powder? Baking soda is sodium hydrogen carbonate. Okay, baking powder is a mixture of sodium hydrogen carbonate plus any edible acid. Okay. Normally what acid we use? Tartaric acid. This is baking powder. Baking soda is sodium hydrogen carbonate only. It is basic, but in baking powder you have sodium hydrogen carbonate along with an edible acid. Okay, just write your doubts, I'll answer it. Hello. So I gave you time for answering for your doubts though. So what doubts you have? Let's read them. Then we'll proceed. Okay. It was still you had doubts, so yes, Sudhanshu, ask your doubt. Hi, Kronks. Okay. You did not ask any doubt. You're just saying you have doubts, but you did not ask any doubt. Okay. Oh, thank you, Rama. Okay. Hi, Yash. Good, Rama. Hi, Sagar again. Arey Abhay, thank you. Yes, that is very nice. You know Sanskrit. Yes. Okay. Hi, Prince. Hello, Manish. Yeah. Thank you. Yes, it is a CBSE batch. Conan, it is a CBSE batch. Hello, Aarti Singh. For Manish, for baking purposes, baking powder is more preferred. Okay, because it has that acidity in the salt that is formed now when sodium hydrogen carbonate combines with that tartaric acid. That salt has little very fruity and very nice taste. Okay, so that's why for baking purposes only you use NaCO3 and this one, baking powder. Baking soda you use when you want to fluff stuff out because it gives carbon dioxide, and carbon dioxide say everything will enlarge. So pakoras and everything, if you want to fry them and you make big pakoras, so you use sodium hydrogen carbonate, which is baking powder. Baking soda is used for making pakoras, and baking powder will be used for making for baking purposes. If you are baking anything, muffin, cupcake, anything, cake or something. Hi, Conan. Hold on a second. Happy birthday to your brother, Abhinav. Okay, Conan, my name is Ekta. I'm Ekta, ma'am. काफी सारे हैं. What kind of sound is coming? Is it echoing? Okay, so Rama, everyone tell me actually, is my voice echoing? Is it not clearly audible to you all? Hold on a second. Everyone just reply if my voice is having any issue. Is it not audible? Is it echoing or something? Just tell me how am I audible? Am I clearly audible to you all? Sorry, no. Yeah, okay, clear. So Aarti ko some are saying not audible. Aarti, okay. Yes, no was for echoing. Okay, Mani. Okay, sure. Done. Then, okay, where are your doubts, guys? Just tell me your doubts. What doubts you have? We can solve them. Okay. I was waiting for your doubts. No doubts came. Ma'am, I have a doubt. But none of you asked any doubt. That is not a doubt. Okay. So, Conan, my name is Ekta. As you have seen in the video also. I'm your Ekta ma'am. Okay, Aarti. Hi, Deepika. So, static, that question is biology related. My biology is very bad. And, but I can help you, I think, this one question. Pepsin digest protein, right? So yeah, amylase. Amylase digest carbohydrates. Okay. Hi, Siddharth. I'm good, Deepika. How are you? Bobby, that question does not come in your exam, but for UQT, you need to know what U, Q, and T means. Okay, okay, sorry. So that was, okay. So Rama, you had doubt about Chlor-Alkali process. Yes, Manish answered your doubt. Recrystallization, friends. So recrystallization is a technique we use to purify any organic compound that we synthesize in laboratory. So whatever we synthesize, that need not to be 100% pure. So what do? We recrystallize it. What do? We take some amount of it or all of it and we dissolve it in a solution. Basically, we dissolve it in a solvent in which it is partially soluble at room temperature, but if you increase the temperature, the solubility will increase. Okay. So let's say normally we use ethanol. Okay, so it is partially soluble in ethanol, but if you increase the temperature, it will get soluble in ethanol. So what will happen? You will what do? You dissolve it in ethanol. You synthesize. You heat it, and then it is soluble. After it is soluble, what you do? You kept it aside at room temperature, because at room temperature that organic compound is not soluble in ethanol or in that particular solvent. So what will happen? Crystals will form of that particular compound, okay, and that's how you get impurities will be there as in the soluble part, जो part पानी में है, that part will become your impurity इसमें चला जाएगा, and the crystals will be formed of your pure organic compound. That's how you use it. So that is for your lab practicals next year, maybe, yeah, next year. Okay. Hi, Akshay. So for please, okay. Okay. Kirti Thakur, Kirtika. What doubt you have? Okay, let me start with the questions. Sorry, you don't have any doubt regarding to, I'm asking any doubt regarding to your CBSE 10th class board, okay? These questions should be answered, we have other time. This is your crucial time. You need to study for your board exams. Really, focused and everything. So, try not get distracted. Apart from anything else, you have 11th class and everything. For now, focus on your boards, which are starting from 17th February. You have only 29 days. Okay, Sagar, tell me your doubt. Catenation and roasting. I'm thinking you're saying, so static, I believe you're saying calcination and roasting. That is coming. Next reaction, I believe. Next to next page over there. Okay, why should curd or sour food not be kept in brass or copper vessel? Because it turns poisonous. Copper and brass vessel, they react with the you call them curd, or anything you take that has acid actually, and you get a poison. So that's why you should not consume anything that is kept in copper or brass vessels. Okay. Because poison ban jata hai, simple. The explanation is when you put curd in brass or copper vessel, it turns poison because copper reacts with the lactic acid and it turns into poison, and that's why you should not consume it. Yes, it gets a poisonous, becomes a poisonous salt. This will react with acid. Hello, Agam. Okay, so moving on to the next reaction. Formation of plaster of Paris. And anyone had any doubt about gypsum? Come here. This is your gypsum. Okay. Lactic acid. Sagar, lactic acid is present in gypsum. Okay, so how do you synthesize plaster of Paris? So you take gypsum. What is gypsum? Gypsum is, this is gypsum. This is gypsum, calcium sulfate, salt of calcium sulfate. Calcium sulfate किसका salt है? Calcium sulfate is a salt of calcium hydroxide and sulfuric acid, right? So it is a neutral salt. Calcium sulfate reacts with, what do? You remove some water, you heat it. At what temperature you heat it? Around 373 Kelvin, which is 100 degrees Celsius. Which is 100 degrees Celsius. So if you heat gypsum at around 100 degrees Celsius, it loses 1.5 water of crystallization. It loses 1.5 water of crystallization, and we get plaster of Paris. This is plaster of Paris. Okay, this is plaster of Paris. Why do we call it plaster of Paris especially because at that time gypsum was only found in Paris. That's why you call it plaster of Paris. Okay, you know, you use it for smoothing hard surfaces, for mending fractured bones. That's why where you use plaster of Paris. Okay, now what happens if plaster of Paris is heated above 373 Kelvin? So actually it's not plaster of Paris. If we heat gypsum above 373 Kelvin, we get plaster of Paris. POP, plaster of Paris. Okay, but if we want to get gypsum back, we add this 3.5 water of crystallization, and that's how we get gypsum. So gypsum, say heat gypsum at 100 degrees Celsius, you get plaster of Paris. Plaster of Paris at 3.5 water of crystallization, you get gypsum. Okay. Next one is metals with oxygen. How do metals react with oxygen? Sagar, ask me specifically. Tell me specifically what you want me to repeat. I will repeat it. No worries. Gypsum is heated at temperature. It loses water molecules and forms plaster of Paris. Yes. Dead burnt plaster. Yes, this is dead burnt plaster. So if you heat it, बहुत ज़्यादा heat कर दिया. If you heat gypsum above 373 Kelvin, so yes, it loses all the water of crystallization. It loses all its water of crystallization, and what we get? Yes, this is dead burnt plaster. It is of no use. It is dead burnt plaster. Yes, correct, Agam. And yes, static, when metal combines with oxygen, we get metal oxide. And what is the nature of metal oxide? Metal oxides are basic in nature, because when you add water to a metal oxide, you get a base. Okay, so when metals combines with oxygen, we get metal oxide. Okay, if we add water to metal oxide, we get a base. Simplest example we can take, we can start from potassium. You want to start from? Let's start with sodium. Combines with oxygen, we get sodium oxide, right? And if sodium oxide combines with water, we get sodium hydroxide. We get sodium hydroxide. Metal oxides are basic in nature, non-metal oxides are acidic in nature. So static, one more thing is there that I will explain to you in the next slide. For now it is clear, metals combine with oxygen, formation of POP. So Sagar, how do we form POP? Simply, so no. You have gypsum, right? What is gypsum? Gypsum is a salt of calcium sulfate. Firstly, you take calcium hydroxide and you combine that with sulfuric acid. That's how you get calcium sulfate. Calcium sulfate, in calcium sulfate, if you add 2 waters of crystallization, that's how you get gypsum. That's how you get gypsum. Yahan tak clear? Everyone, everything clear till now? Okay. So if you heat gypsum above 100 degrees Celsius, what will happen? It will lose 3.5 water of crystallization. Okay? It will lose 3.5 water of crystallization and we will get plaster of Paris. We will get plaster of Paris. This compound is called plaster of Paris. That means it has half water of crystallization. It has only half water of crystallization. It is a salt. किसका? Calcium hydroxide and sulfuric acid. It is a salt of calcium hydroxide and sulfuric acid. Okay, and it has half water of crystallization. Okay, that's how you synthesize POP. Now, what happens if you do not control the temperature somehow? If you just heat it, let it go above 100 degrees Celsius also. So what will happen? If you heat gypsum above 100 degrees Celsius, so it will lose all the water of crystallization. It will lose all the water of crystallization, and what will happen? You get dead burnt plaster. You get dead burnt plaster. Dead burnt plaster. Okay, that was it. I hope it is clear to you, Sagar, now. Yes. We get POP lose 3.5 water of crystal. Okay. Now, what happens when metals combine with oxygen? We get metal oxide. Metal oxides are basic in nature. Why do we call they are basic in nature? Because if you add water to a metal oxide, you get a base. If we add water to a metal oxide, we get a base. So for example, if we have sodium is a metal, right? So if we add oxygen to it, we get sodium oxide. Sodium oxide, if you add water to sodium oxide, you get a base, sodium hydroxide. Okay, now in bases also, you know, we have bases which can be water soluble or cannot be water soluble. Bases can or cannot be water soluble, but alkalis are those bases that are water soluble. Okay, that is the difference between a base and alkali. Next reaction. See, metal only form basic oxide. Okay, remember this one thing, metal only form basic oxide. Okay, now what about non-metals? When non-metals combine with oxygen, we get non-metal oxide, and normally we say, generally we say कि non-metal oxides are acidic in nature. Why? Because when you combine a non-metal oxide with water, you get an acid. That's why they are acidic in nature. But there are some cases where you get a neutral oxide also. Okay, non-metal oxide are also neutral in nature. Okay, they can be acidic or they can be neutral. Okay, acidic plus neutral. They can be acidic or can be neutral also. So we get non-metal oxide. I'll explain with an example only. So let's say if you have carbon combining with oxygen, we get carbon dioxide, right? If you combine carbon dioxide with water, we get an acid, which is carbonic acid. Clear? If we combine carbon dioxide with water, we get carbonic acid. But there are certain non-metal oxides that are neutral. For example, carbon monoxide. Carbon monoxide is a non-metal oxide, but it is neutral. Nitrogen oxide. Okay? For now, remember these two examples. They are important. Okay? Okay, Agam. Next one, metals with water. How do metals react with water? So firstly, not all metals, three type of reactions are there majorly. Either metal will react with cold water, or metal will react with hot water, or they will react with steam, which is water vapors. Okay, so what are we doing? We are increasing the temperature. Why are we increasing the temperature? Because, my dear kids, we have seen the reactivity series, right? Few pages back we have seen the reactivity series. In that reactivity series, as you go down the series, the reactivity of that particular metal decreases. So reactivity decreases, but we want it to react with water. So what will we do? We will increase the temperature. We will increase the temperature of water, and because of that increase in temperature, they will react. कौन react करेगा? Who will react? The metals who are less reactive. The metals who are less reactive will react. Okay. So metals react with cold water, and what do we get? When metals react with cold water, what do we get? We get oxide. Solution have pH. So official is taking your Viva or demo? Sorry. Yes. So normally cold water say sodium, potassium, calcium. They react with cold water. With hot water, what do you have? Iron. What is going on? Yes, magnesium reacts with hot water. Aluminum also react. No, aluminum reacts with steam. Iron reacts with hot water. Yes. Steam, sorry. Okay, how does amphoteric oxides react with the metal? Firstly, we have two, aluminum oxide and zinc oxide. Okay, so how do they react with the metals? Let's say we have an amphoteric oxide, which is aluminum oxide, reacting with, we have an amphoteric oxide, aluminum oxide reacting with a base. So whenever an amphoteric oxide reacts with an acid, it acts as a base. Whenever an amphoteric oxide reacts with an acid, reacts with a base, it will act as an acid. If it reacts with an acid, it will act as a base. So here it is reacting with a base, so it will act as an acid, and we get salt plus water. We get salt plus water. And similarly, if we treat it with an acid, salt plus water. We get salt plus water. Okay, moving on to roasting. What is roasting? Roasting, firstly, which kind of ores we do the roasting? Which kind of ores we do the roasting of? Yes, so conversion of sulfide ores. Yes, we take sulfide ores and we treat them in presence of excess oxygen. We treat them in presence of excess oxygen. That is roasting. So if you have a sulfide ore, okay, you have two type of ore, sulfide ore or carbonate ore. In reactivity series, you can identify metals as metals of high reactivity, metals of medium reactivity, and metals of low reactivity. Okay, then there exist silver, gold and platinum, which are present in their native state because they are not reactive at all. Okay. Yes, calcination. Yes, Sagar, ask your doubt. Calcination. Good morning, Tushika. Yes, ask your doubt. Whatever doubt you have, ask it. I'll answer it. So zinc sulfide. If we take a sulfide ore and we heat it in presence of excess oxygen, heat it in presence of excess oxygen, what will happen? We get sulfide ore gets converted into oxide. Sulfide ore will get converted into its oxide, and we get zinc oxide plus SO2. So after this, what we do, this is oxygen, right? We want to remove the oxygen, and removal of oxygen is called reduction. So we do reduction of this. If we do reduction of a metal oxide, what we get? We get metal. We get free metal. Okay, so that is how you proceed when you are extracting ores which form sulfide or carbonate. So if you have a sulfide ore, you heat it in presence of excess oxygen, and that process is called roasting. Okay, by roasting you get an oxide ore, and if you do the reduction of that oxide ore, you get the pure metal. Okay, obviously after that purification is done, refining and everything is done, but that's how you get your pure metal. Yes, Sarvesh. Yes, black color layer is formed on silver. That is because of silver sulfide. Silver reacts with the sulfur gas present in the atmosphere and gets turned black because of the formation of silver sulfide. And this is the reaction. This is the black color thing that you get, black deposit. Steam, Sagar ka doubt kya tha? Steam question. If corroded silver, yes, SO2 is a pungent. Okay, you do tell me your doubt though. Steam, what steam? Hi, your name is, what is your name? ZJHTNXIDK. IDK I can recognize, but what's your name? Okay, so official KGOS, I hope your doubt is clear. Copper also turns, copodoms, and also they get degraded because of the formation of copper carbonate. Yes. Yes, good morning Hitesh. Is case of reaction between magnesium oxide and aluminum. Which reaction are you asking? Magnesium oxide and aluminum is a displacement reaction. Magnesium oxide reacts with aluminum A, B, oh. So normally magnesium is more reactive than aluminum, so aluminum won't be able to displace magnesium first of all. This reaction won't happen. Why black in color? Sorry, the black color is due to the formation of silver sulfide, right? So why, what's so special about it? Yes, ask your doubt. Yes, Sagar, what steam? I want me to repeat the steam one? Bapre. Hi everyone. Good morning, Money. What is the corrosion stop to prevent silver? So for preventing corrosion, you have some techniques. Either you paint it, or either you do for majorly for iron thing, you do galvanization. Okay, so that is you coat it with a layer of zinc, because zinc is more reactive. That's how you stop the corrosion. Then you can paint it with oil, grease, coat it with grease and everything. So that helps for the iron objects actually. Silver one ke liye to keep it inside. Carbon. No, it's not my birthday. Prevent iron, can do the layer of grease, oiling, painting, coating of zinc. Okay. Next reaction. Calcination. What is calcination? Again, heating in absence of oxygen. And who do we heat? We are heating carbonate ores here. We are heating carbonate ores here. So, if we take a carbonate ore and we heat it in absence of oxygen, we get zinc oxide and carbon dioxide. Okay, now again, we are converting any calcination, means we are heating any carbonate ore. Firstly, calcination means carbonate, Cc, right? Calcination, carbonate. Okay, so if you have any carbonate ore and you heat it in absence of oxygen, that is calcination, you get metal oxide. Again, you get an oxide, and finally you do the reduction. If you do the reduction of any metal oxide, we get the metal back. Okay, we get our pure metal. Now thermite reaction is very important. This is asked multiple times. So what is a thermite reaction? So you take iron oxide, reacts with aluminum, and we get aluminum oxide plus iron in molten state. Now this reaction is plus lots of energy is released. Now this reaction is highly exothermic. Highly exothermic. Highly exothermic means lots of heat energy. Lots of energy is released. Lots of heat energy is released. Okay. Plus you are getting molten iron. Okay. So that must be a really high temperature, right? Because iron does not melt at some little temperature. You need to increase the temperature to a really great extent. Okay. So only at that temperature it will melt. So that means the temperature is really high. Temperature is above 500-600 degrees Celsius. Okay. So this molten iron is used to repair the broken railway tracks. This molten iron is used to repair the broken railway tracks. That is the purpose of thermite reaction. Okay, the main purpose is to get molten iron. Plus the reaction is highly exothermic. Okay, this is a thermite reaction. Okay. Hello, Mohit. Yes, it is used to fill the cracks in the railway tracks. Divya, what do you want me to repeat? Can calcination be in limited supply of air? Calcination is in the absence of air because you already have carbonate or oxygen is already there. So you do not need extra oxygen. Yes, Agam, that is correct. Yes, in absence of oxygen. Hi, Smile Preet Singh. Hello, hello everyone. Sagar again started. Hi. Hi, Smile Preet Singh. Aluminothermy is what? It's not required for your exam. So whatever is required for exams, focus on that. Extra knowledge is extremely faltu for you. No use of that. Okay, moving on. Combustion of hydrocarbons. So means we have done 3 chapters. We have done chemical reactions and equations, acid, bases and salts, and metals and non-metals. So we are on to the last final reactions. Okay. Combustion of hydrocarbon. Combustion means you are adding oxygen. In a limited supply? No, you are providing jitna oxygen chahiye utna lo and give heat and light. Take as much oxygen as you want and the resultant is heat and light. Okay. Carbon dioxide plus heat and light. Okay. That is combustion of hydrocarbons. Again, hydrocarbons means carbon and hydrogen ke compounds. Simple, right? So how do you combust them? You provide oxygen. So there is a thing. Students do get confused between combustion and oxidation. So I'll clear it for you guys. So in combustion and oxidation, the difference is in the products plus the supply. Okay, so in combustion you are providing unlimited supply. Okay, you are giving as much oxygen as the reactant needs and you are getting heat and light. But in oxidation there may or may not you get heat and light, but the supply of oxygen is limited. Okay, in limited manner you are adding. Okay, only this much oxygen is required, so I'm taking only this much oxygen. Okay, so oxidation is the addition of limited supply. Addition of oxygen is in limited supply. But if you are providing oxygen in an unlimited supply plus you are getting heat and light also out of it, so that is combustion. Okay. Hello Rahisha. So Ritika, fatty foods are packed in nitrogen gas to stop rancidity. What is rancidity? Rancidity is the oxidation of oily and fatty foods. Oxidation of oily and fatty foods. That means there is oxygen involved, right? So if you cut off the supply of oxygen, there will not be any oxidation happening. There will not be any rancidity. Okay. So to prevent the rancidity, we flush them with nitrogen gas. Okay. Molten state में कितना temperature होता है? Please tell ma'am. Molten state of iron, are you asking? About 1500 degrees Celsius. Okay, hold on a second. So all things, the temperature is around 1500 degrees Celsius, 1500 degrees Celsius. So Rahisha, I will teach the chemistry portion, then Aditi ma'am will teach you the physics portion, and Jasmine ma'am will teach you the biology portion. Okay. You know, it is actually about 1000 degrees Celsius. It's around 1000 to 1500 degrees Celsius because only about that temperature iron will melt. Okay. Combustion of hydrocarbons. We were on combustion of hydrocarbons. So firstly, methane se shuru kare. Let's start with methane. Okay, we are provided it oxygen. We will get CO2. hydrogen is there, so there will be H2O plus heat. This is a combustion reaction. This is a combustion reaction plus heat and light. Similarly, if you take any hydrocarbon, let's say if I take methane, if I take ethane, I have left math for so long I forget the identities also. Okay, C2H. Yes, C2H5OH. Static asked a question. Okay, this is the combustion of hydrocarbons. Okay, so when you combust a hydrocarbon, you add oxygen. The product are carbon dioxide, heat and light. Okay, next is oxidation. Oxidation of alcohols. Okay, how do you oxidize alcohols? What is oxidation? Addition of oxygen, right? So let's start with the alcohol. That is the only alcohol that is asked in your 10th class chemistry. Do not need to go for any other alcohol. Just remember all the reaction of this particular alcohol, which is ethanol. This is ethanol. Only this alcohol. All the reaction of this alcohol are very important. Okay. Limited reactions are there. Ethanol and ethanoic acid, yes. Okay, so when you oxidize alcohol, oxidation means addition of oxygen. So that means one additional oxygen will be there. You will add one more oxygen. It already has one oxygen. If we add one more oxygen, what will happen? If we add one more oxygen, what will happen? It will turn into acid. It will turn into acid. Functional group क्या होता है acids में? This is the functional group of an acid. It looks similar to this one, right? Just one more oxygen is there. It has this one more oxygen. Okay, it is visible. So it has this one more extra oxygen is there, okay? So if we oxidize it, if we add one more oxygen to ethanol, we will get ethanoic acid, okay? So we have and for oxidation, we have acidified K2Cr2O7 or alkaline KMnO4. These are oxidizing agents. Again, your oxidizing agents are those substances which add oxygen, which provides oxygen, okay? So an oxidizing agent is a substance that adds oxygen, right, and gets reduced itself. So that oxidizes others and reduced itself, okay? Yes, Agam, come back time. Sagar, what do you want me to repeat? Please write the name of the reaction. K2Cr2O7, and that's why you get CH3COOH, which is ethanoic acid. What is the common name of ethanoic acid? What is the common name of ethanoic acid? Tell me the common name of ethanoic acid. Yes, they are strong oxidizing agent. Strongest still HNO3. Nitric acid is still the strongest oxidizing agent. Okay, they are strong, but they are not as strong as nitric acid. Yes, Sagar, what do you want me to repeat? Acetic acid, correct, Sanjay. Acetic acid, Ritik answered also correctly. Then you have in homologous series, mass is different, then it belongs to isomers. Isomers have same mass. What are you asking? So isomers mein the structure arrangement is different, right? But in homologous series, each member differ by 12 to 14 units. Around 14 atomic mass unit difference is there. Yes, acetic acid. Static, what was your question? Static. Yeah, your question is lost. Isomers have different structural formula. Yes. Same molecular formula but different structural arrangement. Yes, structural formula. No, don't worry, Sanjay. They won't ask 9th class syllabus, but they will check your knowledge for 10th standard at least. Hi, Khushi. Okay. Homologous series and isomers are totally different. Isomers have same molecular formula, right? So if they have same molecular formula, तो molecular mass भी same होगा, right? Okay, moving on. Addition reaction. So firstly, you have two type of hydrocarbons: saturated hydrocarbons and unsaturated hydrocarbon. What is the difference? Saturated hydrocarbons does not have a double or triple bond. They all are singly bonded. Okay. That are saturated hydrocarbons. Unsaturated hydrocarbons are hydrocarbons that have double or triple bond, that have unsaturation. Okay, so alkanes are saturated hydrocarbons, alkenes and alkynes are unsaturated hydrocarbons, right? Addition reaction ka matlab there is something getting added. Addition reaction means something is getting added. And what is getting added? And where can you add something? Where there is a possibility of adding, right? You can add something only if there is a possibility of adding. So that possibility is only with the unsaturated compound. So addition reactions are shown by unsaturated compound. Why there is a possibility? If some of you might ask, see, we have in alkanes we have carbon-carbon single bond. In alkanes we have carbon-carbon double bond. Okay, so in here no new bond can be formed. You can't add anything. What you can do, you can already, if it has one compound, one atom here, what you can do, you can just kick it out and substitute it with another atom. You can just kick this atom out and substitute it with another atom. But in here there is a possibility. You can break this bond. You can break this bond and add a compound, and add an atom, compound, whatever you want to add. Okay, so addition reactions will be shown by only unsaturated compounds. Only unsaturated compounds. And saturated compounds will show substitution reaction. They will show substitution reaction because nothing can be added. All four bonds are there. Everything is singly bonded, right? What you can do here, you can replace the already existing atom or compound in that particular atom or group in that particular compound with another atom or group. Okay, that is substitution. I am standing here, some other teacher will come and take my place. That is substitution. But if I am the only one teaching all three subjects, then there is a possibility of addition. We can add for chemistry, physics faculty, we can add a biology faculty. Okay, so that is the difference between saturation and unsaturation. Saturated compounds and unsaturated compounds. So unsaturated compounds will show, hello Kirti, unsaturated compounds will show addition reactions, while saturated compounds will show substitution reaction. Okay, so for example, hello Kirti, this is one of the most most commonly asked, or you can say one of the most important reaction, addition reaction of alkenes. So if we add hydrogen in presence of either nickel, platinum or palladium, who do we get? Clear? So what is happening here, I'll simplify it. This bond is getting broken. If this bond is getting broken, that means you need one hydrogen for this carbon and one hydrogen for this carbon, and we have two hydrogens. H2 is there. Okay, so they will get added and we will get, these will get added and Okay, this is your final product. This is a reaction, addition reaction. This reaction, what is the name of this reaction? Firstly, this reaction is called hydrogenation reaction. This reaction is called hydrogenation reaction. Hydrogenation reaction. So in hydrogenation reaction, what are we doing? We are taking an unsaturated compound and we are adding hydrogen to it and converting it into an saturated compound, right? This is a saturated compound. All are single bonds. Okay, can we add any new bond here? No, because all bonds are fulfilled. All bonds are fulfilled. Okay, there is no unsaturation. Okay, so how to Mr. Jatni, so don't worry, we have that also to distinguish between alcohol and carboxylic acid. Yeah, sodium. Okay. Catalyst, yes, in this thing we used a word, these are catalyst. Nickel, platinum or palladium, these are catalyst. Okay, what does a catalyst do? A catalyst increases the rate of a reaction. Okay, so let's say if a car is going 50 kilometers per hour and if you added some good engine to it and it is going now 120 kilometers per hour, so obviously what happened, we added a catalyst to it. Okay, it increases the rate increase now, the car ka rate increased. So that is, what is that? That is the that is a catalyst that increase the rate of a reaction. Okay, similar way, if this reaction is going initially, if this addition is very slow, so that's why we add nickel, platinum, palladium. What they do, this addition becomes very fast. Okay, the rate increases very fast, like alkaline and acidified, because they just add only these. If the medium is acidified, that only in that medium it will act as an oxidizing agent, and if the medium is alkaline, only in that medium KMnO4 will act as an oxidizing agent. इनके पास होगा oxygen देने के लिए, they will have the oxygen to give. Okay, because only in these conditions. Mohit, at what temperature? There is no specific temperature. They're gonna ask you. Don't worry. If you just do this, they will give you marks. It is there. Okay. This is addition reaction. Then substitution reaction. Hydrogenation reaction is a reaction in which addition of hydrogen is done to an unsaturated compound and it gets converted into saturated compound. Clear? What do we do normally use it for? We take these unsaturated compound. We have oils, and this is fat. So normally your oils are unsaturated compounds and your fats are saturated compounds. So if you want to convert oil into fat, unsaturated compound into saturated compound, what do? We do hydrogenation. What do? We do hydrogenation. We do hydrogenation. Okay. I believe in your houses, if you have seen it, dalda that comes now, that is prepared from oil. So what do they do? They pass hydrogen gas in presence of nickel catalyst, and that's how they do hydrogenation. And vegetable oil, it gets converted into fat, which is dalda, that we use in our homes. Actually, it is not healthy, not safe. So normally it is said that saturated fats are not healthy for us humans, so we should not consume it. Okay, because it increases cholesterol and it gives health issues. Okay, so that's why you should use unsaturated compounds. That's why you should use unsaturated compounds, which are your oils: olive oil, sunflower oil, coconut oil. Okay. Okay. In my exam, a question came. But ethane, yes, that bromine water is there definitely in your syllabus. Don't worry, that is in your syllabus. Bromine water test. Yes. So yes, a bromine water test is used to distinguish between unsaturated compound and saturated compound. So what happens is your unsaturated compound your unsaturated compound, so you have bromine water. which is reddish brown in color. Okay, so if you add bromine water to a saturated compound, so if you add a bromine water to a saturated compound, so compound alkane ke upar you add it, okay, so what will happen if you add it to a saturated compound, it won't decolorize, it will retain its color, it will still be reddish brown in color. So if in a test tube you have इसमें you have a saturated compound and in this you have an unsaturated compound. Okay, so what will happen if we add bromine water to it, if we add bromine water to both actually, so for saturated compound bromine water will not lose its color, okay, it will still be reddish brown in color. Okay, RB means reddish brown. Okay, but if you put that bromine water in unsaturated compound solution, what will happen? It will decolorize, it will lose its color, no color, it will lose its color. Okay, so that is a test that is used to distinguish between a saturated compound and unsaturated compound. So if you have, let's say a simple example, one bottle you have oil and the other bottle you have ghee. Okay, so if you put bromine water in ghee, it will still be reddish brown, it won't lose its color. But if you put bromine water in oil, what will happen? It will lose its color. Okay, we will have no color, it decolorizes bromine water, no color, no reddish brown color. Okay, yes. So this test is actually, I believe in the sample paper only this question was there about the bromine water test. Okay. Okay, after this we have reaction, substitution reaction. So substitution reaction is shown by saturated compounds. Okay, substitution reaction is shown by saturated compounds. Okay, substitution reaction. Methane. So saturated compound will show substitution reaction. Okay, so if we add chlorine to it in presence of sunlight, okay, so one hydrogen is substituted by a chlorine. This is a substitution reaction. They're not as important, but you should remember it. Oxidation is very important. Then how to distinguish, this bromine water test is important, yes, to distinguish between saturated and unsaturated compound. Then you have distinguish between ethanol and ethanoic acid. So what test? Two tests are there. Litmus paper test and reaction with sodium hydrogen carbonate. Okay, litmus paper test and reaction with sodium hydrogen carbonate. So again, ethanol and ethanoic acid. Ethanoic acid is an acid, so it will turn red litmus blue. Ethanoic acid will turn chloromethane. Yes, chloromethane we will get. Yes. Yes, Tejas, CCl4. It's a solvent. CCl4 is a solvent. Normally it is used to dissolve organic compounds which are insoluble in water. Okay. Okay, Manish is asking a question. Okay, hold on a second. Catalytic hydrogenation. Okay, your questions are moving. Wait a minute. Yes, all things catalytic hydrogenation, that's what I discussed with you. If you take an unsaturated compound, if you add hydrogen to it in presence of nickel, platinum or palladium, that is called catalytic hydrogenation. Okay, not catalytic, but it's catalytic hydrogenation. Okay, ethane decolorizes bromine water, whereas ethine don't. Firstly, ethane does not decolorize bromine water. Ethene decolorizes. So this assertion is wrong actually. Mixing of water and alcohol is used in radiators of vehicles in cold countries. So firstly, the question does not make any sense. Firstly, but I'll try to answer it, don't worry. So assertion is wrong. Reason is also wrong. Both are wrong actually. Okay, ma'am, different chemical properties of ethanol. Yes, catalytic नहीं, catalytic है. It is catalytic hydrogenation. Okay. Differences between chemical properties. Sanjay, what is your doubt? Hello, Agam. Okay, static. Actually very cute doubt you have. C2H5OH and CH3CH2OH, they are both the same thing. Okay, so it's like if somebody's name, let's say your name is Static Sun, right? Static 7 Sun. So instead of writing Static 7 Sun, I can write S7S, right? So either I can write S7S or I can write your full name, right? So that's the same difference. Okay, I'll explain. So if you have C2H5OH, right? So this is ethanol, right? This is ethanol. Hold on a second. Where did it go? So static sun, see, this is ethanol, right? This is ethanol. So I can write it CH3, CH2, OH. Okay, that's one way of writing. I can write it CH3, CH2 and OH. These lines represent the bonds. Ki inke beech mein there is a bond. There is a bond in between them. Okay. But see, if I want to write simply, if I want to simplify it, I'll count the number of carbons and number of hydrogens. So I'll count 2 carbons, C2, 1, 2, 3, 4, 5 hydrogens, H5. And this I want to distinguish. I want to show ki yes, there is a functional group there, so that you can easily identify if it is an alcohol or an aldehyde or an ketone. Okay, so OH, right? They're same na, CH3, CH2, OH, C2H5OH. It is just a shorthand way of writing, and this is a little bit open way of writing, or more what do you say, expanded way of writing. Okay, nothing else. Don't worry. Okay, I hope your doubt is clear now. So it's just a shorthand writing method, nothing else. Sanjay, what is your doubt? I asked you. Catalytic hydrogenation, all things I told you. Catalytic hydrogenation means when you add hydrogen in presence of nickel to an unsaturated compound so that it gets converted into a saturated compound. That is catalytic hydrogenation. You are adding hydrogen in presence of a catalyst. That is catalytic hydrogenation. Okay, heteroatom is any atom except carbon, hydrogen. You have oxygen, nitrogen, sulfur. These all are heteroatoms. We call them heteroatoms. Okay. Alcohol is mixed with nitrogen water, pressure and put into liquid form. Yeah, that is for your 12th class solution chapter. Okay, that's needed there, not in your 10th standard, trust me. Papre. Oh. Yes, structural formula, condensed formula done. Yes, so I was discussing that only. If you, this litmus test is one. So if you add litmus, if you have litmus paper, so ethanoic acid will turn blue litmus red. Ethanoic acid will turn blue litmus red. not, but ethanol will not turn, obviously, because ethanol is not an acid, right? So okay, when you chemically, if you want to distinguish, so Sanjay, if chemically you want to distinguish between ethanol and ethanoic acid, you have one reaction, sodium bicarbonate test. So when you put sodium bicarbonate, when you add sodium bicarbonate to ethanoic acid, when you add sodium bicarbonate to ethanoic acid, there is evolution of, we see a brisk effervescence of carbon dioxide. Brisk effervescence of carbon dioxide. That reaction is right there. I'll explain it. Okay, but with ethanol do not react with sodium hydrogen carbonate and thus do not evolve carbon dioxide gas. Okay, so in a sample, if you have two test tubes, in one you have ethanol and in the other you have ethanoic acid. So what will you do? In ethanol one, if you add sodium hydrogen carbonate, there will not be any effervescence, there will not be any gas released, okay? But if you put sodium hydrogen carbonate in ethanoic acid, what will happen? Evolution of carbon dioxide gas, and evolution means there will be brisk effervescence, okay? Evolution means bubbling. Sorry, brisk effervescence means bubbling of hydrogen, carbon dioxide gas, okay? The reaction we'll discuss here. So, how does ethanol reacts with sodium metal? We have ethanol C2H5OH reacting with sodium metal. Okay. So when ethanol reacts with sodium metal, we get sodium ethoxide plus hydrogen gas is evolved. So if you want to test whether ethanol is there or not, so what you do, you take that solution and you add sodium metal to it, and there will be a pop sound. There will be a pop sound. That means hydrogen gas is evolved. That means ethanol is there. That means ethanol is there. And this is sodium ethoxide. Okay, now dehydration of alcohol. Dehydration of alcohol, that means if you heat alcohol at a very high temperature, what temperature normally you heat it around 443 Kelvin. You heat alcohol at around 443 Kelvin, what will happen? If you heat alcohol around 443 Kelvin, what will happen? Dehydration. Dehydration का मतलब होता है simply, and the meaning of dehydration is removing water, removal of water molecule, removal of water molecule. So I'll just write it for you. Remember, dehydration means removal of water molecule, and conditions, what conditions should you provide? You heat ethanol in presence of an acid at around 443 Kelvin. So normally you take sulfuric acid at around 443 Kelvin and heat it. Okay, so what will happen? Dehydration. One water molecule is removed. Okay. Do you have doubts, or what are you guys typing so long? Water removal, hydrolysis. Wait a minute. It's not in your syllabus, Tejas. Alkaline, it's not. 10th class के syllabus में it's not. Okay, Khushi, what's your doubt? In CBSE syllabus it's not there. Different, afferent and efferent. Out. Sulfuric acid is a very good dehydrating agent. It helps remove the water molecule. It helps in the removal of water molecule. Okay. Sulfuric acid is a very good dehydrating agent. It helps removing the water molecule. Okay. Easily हो जाता है process. Okay. So the dehydrating agent that we normally use is sulfuric acid. Okay. my issue. Okay, so when you do dehydration, what you get, water molecule is getting removed, right? So OH from here and one H from here, HOH, water molecule, right? So what we will get? We will get an alkene. Count. Carbon, carbon, two hydrogens. Now to complete their valency, they will form a double bond. So normally, if it's a little bit advanced, but okay, what happens actually, this oxygen will take this bond with it, okay, and this hydrogen bond will come in between it. So there will be a double bond, and this hydrogen and OH will react, and we get a water molecule. Okay, that is not needed for your 10th standard. Okay, so just skip it, ignore it. Okay, next one is reaction of ethanoic acid with sodium metal carbonate bicarbonate. That is a test that is used to distinguish between ethanol and ethanoic acid. So if ethanoic acid is treated with sodium, let's say we start with sodium hydrogen carbonate. If ethanoic acid is treated with sodium hydrogen carbonate, okay? We get sodium ethanoate, and this gas is evolved with brisk effervescence. And this gas is evolved with brisk effervescence. This is sodium ethanoate. And this test is used to distinguish between ethanol and ethanoic acid based on their chemical properties. Okay, so if you treat ethanoic acid with sodium hydrogen carbonate, what we get? We get sodium ethanoate and a brisk effervescence of sodium carbon dioxide. Khushi, what did you not understand? Dehydrating means removal of water, dehydration. So normally whenever you go out sometimes to play, so if you play too long, what do you have? You have this in अंदर से बहुत ऐसे सूख जाता है सब कुछ, गला सूख गया है, बहुत प्यास लगी है मम्मा. It's like a dried Sahara desert in your mouth, right? That means there is, what is happening? You are dehydrated. Dehydration means water molecules are evolved. क्या हुआ? बाहर गए, एनर्जी गई, धूप में गए, वाटर मॉलिक्यूल्स इवापोरेटेड फ्रॉम योर बॉडी, यू नो, पसीना आया के थ्रू एंड एवरीथिंग, राइट? सो that is dehydration. Similarly, in organic compounds, dehydration means removal of water molecule. Removal of water molecule, right? So where are we adding it? We are removing the water molecule. I hope it is clear now. Saturated hydrocarbon and unsaturated hydrocarbon. So in cow ghee we have any type of ghee or fat. Any type of ghee or fat you have that is saturated, that is a saturated compound. Okay, oils are unsaturated compound. Okay, refined oil and any kind of oil, olive oil, sunflower oil, peanut oil, any oil you use, coconut oil, they all are unsaturated compound. Generally scientists say that you should prefer unsaturated compounds over saturated compounds. So if you are eating, do not try to eat ghee every day. You should use oil in cooking, not ghee in cooking. Okay, but our ancestors have been using ghee. So let's see. Yes, so ghee is saturated and oils are unsaturated. Okay, both are equal, but ghee also does kill cholesterol unless it's pure ghee. Any type of oil is unsaturated compound. Okay, this is one. Then reaction with metal carbonate, same reaction. Reaction with metal carbonate. Same, the product is same, so I'm just putting an arrow there. Okay, the products you will get is sodium ethanoate, water plus carbon dioxide evolving with brisk effervescence. Done? Okay, what about sodium? If sodium ethanoic acid reacts with sodium, if ethanoic acid reacts with sodium, evolution of hydrogen gas. Which gas is getting involved? Hydrogen gas. Okay, this reaction is similar, na? This one, ethanol and ethanoic acid. So you can't differentiate using sodium metal, but you can differentiate using sodium hydrogen carbonate. Hold on a second. Okay, done. Now, esterification, saponification, I would say before going to your exam, just cram these out, okay? Just cram these out because paper mein these will come. Trust me, they will come because they have been asking it. There's a very important reaction one way or other, if not directly, indirectly in some question, in any competency-based question, they will be there, okay? So, make sure do not forget these and remember them, memorize them properly, okay? What is esterification? Esterification means when ethanol and ethanoic, alcohol and an acid combine, when an alcohol and acid combine in acidic medium. Kisme? Acidic medium mein. When an alcohol and acid combines in acidic medium, what do we get? We get an ester. Formation of an ester, okay? That is esterification. Formation of an ester, that is esterification. Okay, so if we take ethanol and ethanoic acid, okay, in presence of an acid, in presence of an acidic medium, okay, in presence of an acid, what do we get? We get an ester. Okay, just one thing, remember it. Hold on a second. So you have this portion coming from here, OC2H5, right? Yes. And okay, so this OH, from here you are taking CH3CO, this portion CH3CO, this portion is coming from the acid, and this other portion OCH2CH3, this is coming from the alcohol. So your alcohol is losing one hydrogen and your acid is losing OH, okay? Alcohol say you are losing one hydrogen and from the acid you are losing OH, okay? And remember, the medium is acidic. You are heating in an acidic medium, okay? And this is an ester, okay? CH3COO, CH2CH3, ethyl ethanoate. Do not need to remember the name, but for this one, just remember it, ethyl ethanoate. Okay? These are fruity smelling, you know, very nice. Esters say you make perfumes. Perfumes are normally made from esters. So I am teaching only chemistry. Alkanoate. All things, it's alkyl alkanoate. It's alkyl alkanoate, that is an ester. That is the IUPAC name of an ester. IUPAC name of an ester. Sanjay, yes, ethyl ethanoate. Clear. Okay, this is esterification, and reverse of esterification is saponification. What is saponification? Reverse of esterification. Saponification means formation of soap. So what do you do? Reverse of esterification. You take an ester, okay, you take an ester and you now you're treating it in acid, right? So acid ka reverse, base. So if you treat an ester in presence of a base, you get alcohol plus acid. You get alcohol plus acid. Remember one reaction. Alcohol and acid combine in acidic medium, we get an ester. Ester reacts with a base. Ester react with a base, we get an alcohol and acid. Clear? Normally this this acid part will be the soap. The acid part will become the soap. Okay, I'll clarify. Ruko. In presence of a base, we had an acid, but now we are reacting it with in presence of a base. Okay. This will become the soap part. This sodium ethanoate will become the soap part. So saponification is nothing but the reverse of esterification. In esterification, an alcohol and acid combines in presence of an acid in an acidic medium to give ester, and reaction of acid with a base will give us the acid and alcohol back. That is saponification. Clear? I hope it is clear now. Yes, Cosmic, bolo. Sanjay, I do not know Tamil. I only know Hindi and English. And little bit Kannada. Are you stating a doubt or providing me the definition? Glycerol byproduct. I know a little Bengali too. Yeah. See, esterification mein, I told you this is ester, right? After making the ester, what is left? Hydrogen from the alcohol and OH from the acid. Hydrogen from the alcohol and OH from the acid. HOH, which is water, right? So that's how you get water. Hydroxyl group with the functional group alcohol, then the reaction formed. Esterification, yes. Yes, it is in the name. Yes, all things. Esterification forming. Okay, hold on a second. So all things, why are you repeating it? I don't know. That is the definition of this esterification reaction. But ester is not written like that. Cosmic, you wanted to say something. Okay. Yes, Akshit, it is soap. Yes, it is soap. That's why it's called saponification reaction. That's why it is called saponification reaction. I believe we are almost done. Dehydration ho gaya. Done. One reaction is left, which is from your biology actually. Let me see. Last reactions are there. Array. Yes, I did right. Saponification I did right? Check it. Okay. Sorry. Again for the doubt. See, this is either I write it as CH2CH3. Okay, this is CH2CH3 only, right? CH2CH3, 2 carbons, C2, 2 hydrogens, 3 hydrogens, 5 hydrogens.
hydrogen, C2H5. That's the same thing I have written. Okay, I just simplified it. Instead of writing CH2, CH3, I just combined all the carbon and hydrogen and I wrote C2H5. Okay, this is a condensed formula. Cosmic, what you want to ask? Sodium ethoxide, when ethanol combines with sodium metal. Okay, when ethanol combines with sodium metal, we get sodium ethoxide. Okay, see, sodium ethoxide and then your sodium ethanoate. There is one extra oxygen. There is one extra oxygen. See, it has only one oxygen, sodium ethoxide, but sodium ethanoate has one extra oxygen. Okay. Yes, respiration and photosynthesis is left. Stearic acid is an acid or क्या है? No, it won't be wrong, okay? If you just condense it or either you write the complete formula, it does not matter, okay? As long as your number of carbons and number of hydrogens are same, it is correct. Do not worry. Agam is answering your doubts, huh? Okay, so I believe we have, okay, last reactions we have. Yes, reaction of carbon with, copper with carbon dioxide. It is a rusting reaction. So just let me finish these two reactions. I will give you 5-minute time for your doubts, okay? Abhi ke liye, what doubt you have? Let me see. Allotropes में what confusion you have? So just पढ़ ले those. Tell me your doubts on allotropes. I'll answer them. Allotropes are see, allotropes they have same they're made up of same same element actually, okay? They are made up of same element, but they differ in the physical arrangement. They show similar chemical properties also, but only physical arrangement is different, okay? Allotropes are made up of same element, but they differ in the physical arrangement. They will show the same chemical properties, but they will differ only in the physical arrangement. For example, you have 3 allotropes of carbon, graphite, diamond and Buckminster fullerenes, okay? Okay, what are allotropes? No, that's not allotropes, Manish. That atomic number but different, that they are isotopes. This is green color. So what happens is copper is this brown color, right? So over time its oxidation happen, and after oxidation it gets corroded as copper carbonate, okay? So copper carbonate, I don't know if you know, in European countries mostly they used copper for making those artifacts, for making those buildings and everything. Okay, so where there that copper was reddish brown. Initially it was like this shiny colored metal, right? But reddish brown color obviously, but with the time it turned green. Okay, that is because of its reaction with carbon dioxide due to its corrosion as copper carbonate. Okay. Last reaction, second last reaction, photosynthesis. What is photosynthesis? Are plants prepare food by photosynthesis? Will you do the sample paper given by CBSE Boards? Yes. So Manish, I've already done it in a live class actually. So you can go check it in the live section. It is there. You can see the sample paper for chemistry. I've solved each and every question, all the odds and for every type of question which are there. Okay. So you can go and check there. Copper carbon copper from further corrosion. It is already corroded. उसे further क्या protect करेगा? So no, it may be form a layer you can say, but copper is mostly corroded if it is turned into copper carbonate. Okay. So that is not important for you. Sample paper question. Okay, so photosynthesis. Our plants synthesize their food using photosynthesis. What do? They take carbon dioxide, and they have water, right? What kind of reaction is photosynthesis? Exothermic or endothermic? Hi Doraemon. What kind of reaction is photosynthesis? Exothermic or endothermic? Exothermic or endothermic? Got knowledge too from here. Okay, so Sumit answered exothermic. Hello Nitish. Okay, so photosynthesis first of all is an endothermic reaction. I was also shocked. Okay, photosynthesis is an endothermic reaction because plants absorb sunlight. They absorb energy. Sunlight may heat energy is there, right? So they absorb energy to prepare their food. Yes, you can ask your doubt because the class will end soon, so do write your doubts down. I'll try to answer them. Okay, so photosynthesis mean carbon dioxide plus water combined in presence of sunlight. This is an endothermic reaction. Okay, because for this process energy is getting absorbed. Okay, so what we get? C6H12O6 plus oxygen gas is a byproduct. That's why you call the photosynthesis is good. That's why you should plant more trees because oxygen is getting released and we need oxygen to survive. Everyone needs oxygen to survive. Okay. Hi Abhay. So if you have okay, so if you have any doubts, please drop them in the comment section or in the live chat. Okay, I'll try to answer them because our portion is almost complete. All the reactions I've done in this sheet itself focus on all these reactions, and apart from that you do not need to worry. Okay, all the reactions are covered by your Ekta ma'am here. Okay, do not worry, you will score good in your pre-boards and in your boards you will definitely score 95 plus. Okay, so we need to balance this reaction first. Okay, we have 6. If we do 6 here and 6 here, I believe it is balanced. 6 here also we need. Yes, 12 12, 6, 12, 13, 18, done. Okay, so this is a balanced chemical reaction, photosynthesis. Okay, this is from biology, but again we are doing the reactions, all the important reactions we are taking, so we are getting mixed up a little bit. In physics you don't have any reaction, you have numericals only. Okay, all things asked. 10th related question please. Okay, only 10th related questions. Respiration. Okay, respiration is exothermic or endothermic? Quick reply. Respiration is exothermic or endothermic? कहाँ से? Okay. Yes. Respiration is exothermic because we do respiration and energy is released. I'm doing respiration and that's how I'm surviving this long marathon. Okay, that's how I'm able to teach you, because of respiration, because my body is producing energy. So respiration mein what you do, you have glucose, we eat carbohydrates, right? In carbohydrates we have glucose, right? And we need oxygen because we are breathing, we need oxygen for respiration, right? We do not need carbon dioxide, we need oxygen for breathing. Okay, and this happens in mitochondria. What is mitochondria? That is a biology question, but everybody knows that. Mitochondria is the powerhouse of the cell. Whenever our teacher used to ask, we used to shout it very loudly. Mitochondria is the powerhouse of the cell. Only this line we remember. And then lysosomes are the suicide bags of the cell. These two things I remember till the day. Okay, so respiration is exothermic. Okay, glucose. This is glucose, right? Where do we get glucose? Carbohydrates. We eat food. We eat rice, we eat chapati, we eat khana, lots of things we eat. That gives us glucose. And we have oxygen. We are in breathing oxygen, right? We need oxygen for respiration. And this reaction happens in mitochondria. Mitochondria is the powerhouse of the cell. So we get carbon dioxide plus water plus energy, ATP. Energy in form of ATP. ATP is adenosine triphosphate. ATP is adenosine triphosphate. It's like a currency, energy currency. For example, India ki currency, we have India's currency as rupees, right? And US dollars. For similarly, in our body, the currency that works is ATP, which is adenosine triphosphate. This is the energy currency. Okay. Okay. Please mention your doubts in the live section. Okay, I will answer them. Okay. Okay. If you want to balance it, you just reverse it now. So we do 6 here, 6 here, and 6 here. So these are all the important reactions, all the important chemical reactions from not just chemistry, from biology also, from this science actually. I hope you learned something from it. Okay, and if you have any doubt, do drop them in the live chat section. I will answer your doubts. And if you have if any other doubts left after this live ended, do drop them in the comment section. And if you like this session, give it a like and subscribe to the channel for more such amazing content. And because we are working very hard for you to score 95 plus in your board exams. Okay, so thank you. And yes, if you have any doubts, let's answer your doubts first. The live is not ended yet. Okay, hold on a second. Exothermic reaction done. So see, copper and conc HCl. Obviously, copper cannot displace because copper lies below hydrogen, so it cannot displace hydrogen from its compound. So what will happen? No reaction. Copper does not react with conc HCl. Okay, glucose combined into 12th powerhouse of the cell done. CO2 energy sensor mitochondria is the powerhouse of the cell done. Potatoes, yes, potatoes. Potato patata. Hello, ma'am. Hello, Angel. Ma'am, I scored 25 in chemistry in my pre-board exam. Now I think I will. Yes, no, whether you can score full. I have trust in you. I have trust in you. Okay, ma'am, I go rupees. Bolo khushi. I. Yeah, that's why you failed in your IT. My doubt is Kids, you should not use any other social media app during this time. Actually, you have 1 month. Prepare for exam seriously, okay? And do not fall into distractions. Okay, you do not have any doubt, I see, my dear kids. Okay, so I guess that was it. You do not have any doubts, so that was it. So do revise these reactions, and if you have any doubt, do drop them in the comment section, okay? And all the best for your boards. Prepare accordingly, and again, we all are here to help you out. If you have any doubts, anything you do not understanding, kahin bhi you have any problem, do contact us, okay? Do let us know. We'll try to help you as much as we can. And yeah, don't be distracted, Sanjay. Firstly, cut all your social medias. That will help you with the distraction, and focus only on studies, okay? If you're studying from YouTube, focus only on that source and revise, okay? Yes, Mission Jeet. Okay, physical games are good, but for some time being, you can focus on your exams only. Just a month now. Okay, thank you so much. Take care. Bye bye, tada. Okay, take care, and do subscribe to this channel, and do like this video. Bye.